Now that you're a master of the unit circle and you've totally memorized all the exact values for our special angles from 0 to 360 degrees, we're going to actually start applying these, because it's not just that we need to know our special angles, we need to actually be able to use them. So we're going to be solving trigonometric equations in this lesson. So we're going to start with example 1, solve sine x plus 2 equals 3 for the whole range of 0 to 360. But you'll notice that there's no underlines here, which means we're not actually going to include 360 or 0 degrees. Okay, when we see the word solve, it is specifically asking us to determine the value of a variable. Okay, and it means that you need an equation. Okay, so we've got sine x plus 2 equals 3. Well, if we take that, we've got sine x, and we would move that 2 onto the other side, so 3 subtract 2 from both sides gives us 1. When is sine of some angle 1? Well, if we think back to our unit circle, sine is our y value, so y is a positive 1 here. We would like to say it's also 1 here, but remember that sine is negative here. It's negative 1. So in this case, x only has one answer, 90 degrees. In example 2, it gets a little bit more complicated. We're dealing with tangent, we're dealing with a square, but the same principles still apply. We're still solving, we are still not including 0 and 360. So first thing again, we try and isolate our function, then peel away the function to isolate x. So we're going to move away the 3 first, reverse BEDMAS if you want to think about that, reverse order of operations. We've got tan squared x. And please note that tan squared x is the equivalent of saying tan x squared, but we never ever write it like this. We always write it like this. It's just a convention. It's the language of math. That's what we're going to be dealing with all the time. So we're dealing with negative 3. We want to take the square root to cancel that out. And so tan x equals the root of negative 3. But what do we know about taking the root of a negative number? What did we learn in our last unit? Well, that's impossible. It's an imaginary number. It's a completely different topic that we're not going to get into. But this is not possible. And so we say that tan x is undefined. But we know that tan x can actually be undefined at different places. Specifically, we recall that tan x is equal to sine x divided by cosine x, which means that it's undefined when cos x equals 0. So you might remember exactly where on the unit circle this occurs, or again, sketch it out, draw your table, look at your unit circle, whatever you need to do. Cos is our x value of any point on the unit circle. So when we're looking at x values that are 0, we're looking at 90 and 270, and so that is actually what x is. So even though tan x is undefined, this is still solvable. So that's a different idea than what we saw in the previous unit, where when we had our discriminant equal a negative value, we could not possibly solve for x because we were just taking the square root. But because tan is a different function and tan is undefined in places, it still can have specific values. So here and here is where cos x equals 0. Now, example 3 and 4 are a little bit more challenging. So the first thing that we see when we look at this is, oh my god, we got squares, we got square roots, we got trig functions, like holy crap. In addition to that, we're not dealing with the full 360, we're only dealing with up to 180. So watch out what your range of values or your domain is allowed to be. So just like in our previous unit, when we had like binomials inside of polynomials, we simplified it. I'm going to do the same thing here. And so I'm going to say cos x is n, and I'm going to rewrite my equation like that. So at least it looks a little less complicated. From here, it's a polynomial. The first thing we do when we try and deal with a polynomial or a quadratic specifically is we look for our greatest common factors. So take out an n and we're left with 2n minus the root of 3 equals 0. Just like before, we've got two factors all set equal to 0. So one of these two numbers that are multiplying together need to be 0. So we've got n is possibly 0, or 2n minus root 3 is 0. Now, you can substitute this guy back in at this point, or you can wait until n is completely isolated. So for my left value, n equals 0, I can substitute it in right now. Cos x equals 0. That happens again, just like in the previous question, at 90 and 270. But because I have this restriction where I can't go past 180, x can only be 90 degrees according to that. Okay, this side is a little bit trickier. I'm going to keep it with n a little bit longer until n is isolated. So I've got 2n equals root 3, or n equals root 3 over 2. If this is the case, then cos x equals root 3 over 2, positive root 3 over 2 specifically. And so we're dealing with quadrants 1 and 2 here, so we're not dealing with 3 and 4. Cosine is only positive in quadrant 1 out of those two, which means I'm only dealing with quadrant 1. And when is cosine root 3 over 2? Well, that is at 30 degrees. And if you had to look at your unit circle or your table, that's totally fine. But at no point should you be punching this into your calculator. This is all non-calculator. It's 30 degrees. And so I have two answers for this question. Our last example is in the same family as the previous one. So I'm going to say let. And you can choose any number you want to represent your trigonometric function, or you can leave your trigonometric function in there. Now just remember, don't switch your variable though, like I just did. Make sure you correct it so that it's always the same. On the provincial exam next year in grade 12, that actually is a half mark off when you switch your variables, so don't do it. Always make sure you stick with what's there, not necessarily what you've been used to working with. So we've got sine x equals, we'll call it m this time. What the heck? So we've got m squared minus m equals 2. Well, dealing with a quadratic, to solve for my variable, I'd want to isolate everything on one side. So m squared minus m minus 2 equals, so it's set equal to 0. And from here, I'm going to try and factor it if I can, since it's in general form. That's how I solve it. So we've got m and m, negative 2. Its factors are negative 2 and positive 1. That adds to the middle. Sum and product rules for that. Okay, so I've got my two options again, so we split, and m minus 2 equals 0. Well, from here, I've got m equals positive 2, so sine x equals 2. At any point on our unit circle, can sine be equal to 2? Now remember that on our unit circle, our radius is 1. So the biggest distance at any point in the circle is going to be just 1. And so this is impossible. If you don't believe me, now is the time where you can pull out your calculator just to check. Try taking the sine inverse of 2, and you will find that x is undefined. Because 2 is a non-permissible value. Our other option is m plus 1 equals 0. So m would be negative 1. Again, we're dealing with sine x equals negative 1. Sine is the equivalent to our y coordinate when we write them out for any unit circle. And I can use theta here because I'm writing a different kind of rule, so it's just a reference. So I'm looking for my y value. Y value is negative 1, only happens here. So that is when x equals 270 degrees. And so I only have one answer despite the fact that this is a polynomial. And that's how we solve these. So when you go to do your homework, if I'm not mistaken, there are some inverse trig functions. Yeah, we've got cosecant here showing up. Just remember that cosecant is the equivalent to 1 over sine. And so what you're going to do is you're going to flip your values for sine theta. Okay, beyond that, these are all kind of in the same family as what you've already been doing. So give them a shot, and once you're done, you can check in with me to make sure you've been doing them right, because I don't think there's an answer key for this one at the back. Good luck.